Hey students, today I will be seeing the conservation of energy. I will be teaching you the conservation of energy. So you know that in the universe there are various forms of energy, and all the forms of energy while you are putting together, it will be constant. It will not change. The total sum of the energy, the total sum of all the energy present in the universe remains the same. There will be no change of the total energy. Maybe you know the various forms of energy, light, heat, electricity energy, sound energy, etc. So many forms of energy are there. Maybe in one case you find the heat energy is decreasing, but in the same way the light energy will be increasing. Now in the same way, if you see in a place the electric energy is increasing, maybe some other form of energy decreasing. So in this way the energy is changing from one form to another, but the total sum of energy remains the same. So this is what is said from the law of conservation of energy. So according to the law of conservation of energy, what is that it says? It says that energy can neither be created nor it can be destroyed. It can only transfer from one form to another. It is written on the board. You can see on board. According to the law of conservation of energy, energy can neither be created. We cannot create the energy, nor it can be destroyed. We cannot destroy the energy. It only changes from one form to another. Whatever energy is there in the universe, it remains the same. All energies, the total energy in the universe remains the same. Maybe the sound energy decreasing, in the same way the light energy may be increasing. So the total energy remains the same. That is what we say the law of conservation of energy. So according to this, again I am explaining you, the total energy in the universe remains the constant. You know that the nature has provided us the various forms of energy. So all these form of energy, while we are putting together, it remains same. There will be no change of the total energy of the universe. So this is the meaning of the law of conservation of energy. Now this we can prove also for a body falling freely under the action of the gravity. If suppose our body is falling freely under the action of gravity and there is no force of friction, we can prove that the sum of the kinetic energy and the potential energy always remains constant for its motion whenever the body is falling freely. Remember that the mechanical energy, that is the sum of the kinetic energy, and the potential energy is the mechanical energy. So the mechanical energy at any point of the motion of the body, you can find this remains the same, this remains the constant. So that we will be showing in the verification, or I will show you how this K plus U remains constant. K stands for your kinetic energy and U stands for the potential energy. This energy remains constant. As I told you, the total energy of the universe remains the constant, which is the law of conservation of the energy. So now I have got the topic for you. The verification of K plus U is equal to constant for a freely falling body. So here we show that when a body falls freely under the action of the gravity, the total mechanical energy of the body throughout its motion remains the same. That is, the sum of the kinetic energy and the potential energy at any point of its motion will be same. Just see one example I am giving you. Suppose one body is dropped from this height. Say for example, the body is dropping from this height in this direction. Now when the body is dropping, or when the body is falling in this direction, what is happening? Here what type of energy the body was having? The body was having the potential energy because it is at a height above the ground. Now when the body falls freely from this height, what happened to the potential energy of the body? The potential energy of the body gradually decreases, and the kinetic energy of the body is increasing. And here the kinetic energy of the body was zero because there was no motion. So at this position, the potential energy was the maximum, isn't it? And the kinetic energy was zero. Maybe the potential energy was mgh, whereas the kinetic energy is zero. So when the body falls, gradually the potential energy decreases and the kinetic energy increases. That means the potential energy from mgh, it is going down, it is moving down, decreasing. If suppose the total energy at this position is 100 joule, Say the total energy at this position is 100 joule. So it is in the form of the potential energy, and at this position kinetic energy will be 0. Now when the body reaches over here, what happened to the potential energy? Potential energy will be not 100 joule. Maybe the potential energy at this position will be here 90 joule, and the kinetic energy at this will be 10. So therefore the total energy over here is given us 100, which was there the initial potential energy of the body. Similarly, when the body again falling down, suppose we will consider at this point. At this point, again what happened? Again the potential energy decreased. Maybe the potential energy at this position will be 60. It was 90. Now it is becoming 60. And here the kinetic energy will be 40. So that the total energy again is giving us 100. That is the total mechanical energy. Again, maybe the body is coming down, again reaching over here, and this is the ground. Now in the ground, if suppose the kinetic energy over here will be 100 and the potential energy will be then 0, there will be no potential energy at this position. So therefore again the total energy is given us 100 plus 0 is equals to 100. So throughout the motion of the body, the total energy, the total mechanical energy, that is the sum of the kinetic energy and the potential energy of the body remains constant, of the body remains the same. So this proof I will show you with the help of a body whenever it is falling freely under the action of the gravity. So this is actually the mechanical energy. Whenever there is an interchange between the kinetic energy and the potential energy, see over there, the interchange between the kinetic energy and the potential energy is taking place. The sum of the total kinetic energy and the potential energy, that is the total mechanical energy at any point of the motion of the body, remains conserved or remains constant throughout the motion of the body. So this I will be showing you with the help of this verification. Now see, in this diagram, let us consider a body of mass m. The mass of the body is m. Here the mass of the body is m, which is placed at a height h above the ground. You can see over there, this is the height h above the ground, and the body is allowed to fall freely. So when the body is allowed to fall freely, what is happening? Initially the potential energy which was having with the body is decreasing and the kinetic energy of the body is increasing. So now in order to prove this, that the total mechanical energy of the body remains constant throughout the motion of the body, we have to show the total energy at position A, the total energy at position B, and the total energy at position C. Let us calculate the total energy at position A. At first we will see at position A. So the total energy at the position A will be how much now? Say me, what is the kinetic energy at position A? Since there is no motion, therefore the kinetic energy at position A will be 0. So K is equals to 0. And the potential energy at this position, U is equals to mgh. Since m is the mass of the body, g is the acceleration due to gravity, and h is the height of the earth. So therefore the potential energy is becoming mgh. Now the total energy at the position A is equals to k plus u, that is equals to 0 plus mgh, which is equals to mgh. That is your equation number 1. So now we could find the total energy at position A is equal to mgh. So in the same way, we will show now the total energy at position B. Now what is happening at position B? So let us write down at position B. So now what is happening at position B? Let us consider the body is falling freely from the position A to position B, and on reaching at position B, let us consider the body is getting a velocity of v1. So therefore the initial velocity of the body was how much? 0. From here the initial velocity of the body was 0. Now here the final velocity of the body is becoming, that is here v1. At this position the final velocity of the body is becoming v1. So let us consider on reaching at position B, the final velocity of the body is v1, and the body cover a distance from A to B, that is your x. So therefore, the height at point B will be h minus x. So now see, at position B, what we are getting here? We are getting the initial velocity u is equals to 0. Final velocity v is equals to, we have considered here v1, and acceleration a is equals to g. Since the body is falling freely, the distance covered by the body from A to B, that is here s is equals to x. We have taken over there. This is the distance which the body is covering. Now let us calculate the kinetic energy at position B. Now in order to find the kinetic energy at position B, we know that kinetic energy is equals to half mv square. So we have to find this v1, because at position B we have considered the velocity of the body is v1. Now we have to find the value of v1 over here. Now how can you find the value of v1? From the equation of motion. So by using the equation of motion, which equation of motion we will be using over here? That is here v square is equals to u square plus 2as. That implies here v is how much we have considered? v1. So we may consider here v1 square is equals to u is 0 plus 2gs is your x. So therefore now we are getting v1 square is equals to 2gx. That means the velocity at the position B is becoming 2gx. Now we find the kinetic energy at position B. So the kinetic energy at position B, after this I am writing over here. This is at position B. So the kinetic energy, I can erase this thing also. The kinetic energy at position B, K is equals to half mv square. So here v1 square, that is equals to 1 by 2 into m into v1 square. How much we got v1 square? 2gx. Put over there 2gx. Now 2 is cancelled. So we are getting here mgx, which is the kinetic energy. Now let us find the potential energy. In order to calculate the potential energy, we have to see the height of the body above the ground at position B. So when the body is at position B, the height will be how much? Height, that is equals to h minus x. H minus x. Why? Because the total height was h and the body is falling down a distance of x. That means from here to here it is taken x. So therefore now we have to find the height from here to here. I will find the total height minus this distance. That means that will be h minus x. So therefore the height at position B is h minus x. Now the potential energy U is equals to mg h minus x. So that is equals to mg x or mgh minus mgx. So now we will find the total energy at position B. Therefore the total energy, now we will find the total energy. So the total energy is equals to K plus U. Now K, how much we got? mgx. That is your mgx plus U, we are getting mgh minus mgx. So mgx is cancelled. So how much we are getting? mgh. That is your equation number 2. See, in equation number 1 we got the total energy as mgh. Now in equation number 2 also we are getting the total energy as mgh. So let us see at position C how much will be the total energy. If at position C the total energy will become mgh, that means our theorem is proved. Our law is proved. We are going to find this only. So let us see now at position C. So now we see at position C. So let us see at position C. Now what is happening at position C? Let the velocity obtained by the body on reaching at position C be v. Because the body is falling freely, I have told you. So the final velocity at position C will be v. Now the initial velocity of the body was how much? That is u is equals to 0. We have considered. So at position C, what we are getting? the initial velocity u is equals to 0, final velocity v is equals to, let it be v, and the distance covered by the body is the total height. So the distance covered s is equals to h, whereas the acceleration due to gravity a is equals to g. So these are the things we are getting at position C. Now in order to calculate the kinetic energy at position C, we have to again find the value of v. Now from where we will find this value of v? From the equation of motion. Which equation of motion? That is v square is equals to u square plus 2as. That implies v square is how much? V square is equals to u square is 0 plus 2g, and it is your h, because a is your g and s is the h. So therefore that implies v square is equals to 2gh. Now kinetic energy k is equals to half mv square. That is equals to 1 by 2 into m into v square. In place of v square you put over there 2gh. Now 2 is cancelled. So how much we are getting here? mgh. And at position C, what is the potential energy? At position C, the potential energy is 0. Why? Because the body is on the ground. So on the ground, the height is equals to 0. Therefore, the potential energy of the body at position C is becoming 0. So therefore, the total energy at position C, that is K plus U, is equals to mgh plus 0. That is equals to mgh. That is your equation number 3. Now see over there, in equation number 1 we got the total energy as mgh. In equation number 2 we got the total energy was mgh, and also in equation number 3 we are getting the total energy as mgh. That means at position A we found the total energy was mgh. At position B we found also the total energy was mgh, and at position C we are seeing the total energy is mgh. So therefore, when a body falls freely under the action of the gravity, the total energy of the body, that is the total mechanical energy, that is the sum of the kinetic energy and the potential energy of its motion remains the same. This we could prove that one with the help of this thing. That is here we are getting the total energy at any position of the motion of the body is coming here mgh, which was the initial potential energy of the body. And I have given you that example. When the body was falling freely, the potential energy gradually decreasing and the kinetic energy is increasing. If the body is falling freely, because initially the body was having the potential energy. So in the same way, if suppose the body is thrown off, suppose at this position one body is throwing off, like this the body is going. So what is happening? At this position the body is having some initial kinetic energy, and say the body is thrown off above the ground. So therefore we will consider the potential energy at this position will be 0, and the kinetic energy is the total energy of the body. That is the total energy. Say the kinetic energy something, maybe the kinetic energy is say mgh. Now when the body is going in the upward direction, what is happening? Gradually the motion of the body is decreasing, the velocity of the body is decreasing, and the height above the ground will be increasing. So when the body goes in the upward direction, this kinetic energy of the body decreases and the potential energy of the body increases. And whenever it reaches at the highest point of the reach, maybe suppose we have taken the height h, at this the body is coming into the rest position. So there the kinetic energy of the body is becoming again 0, because it is the highest point of reach, whereas the potential energy is the initial kinetic energy, that is your mgh. So in this way the total energy every time in throughout the motion of the body remains the same, that is your mgh. Now one question I am asking you, whenever the body is reaching at position C, now what is the velocity of the body? See what is happening over there. When the body reaches at position C, since I have told you at position C the body is having the kinetic energy. So now what is the velocity at which the body is moving at position C? Now we can find this. So at position C or on the ground level we are seeing that the kinetic energy of the body is becoming mgh. So what is the expression of kinetic energy? The expression of kinetic energy is half mv square. So half mv square is equals to mgh. Now mm is cancelled. Therefore v square is equals to 2gh. That implies v is equals to 2gh root over. That means when the body is at position C, the velocity of the body is how much? 2gh root over. With this velocity, the body is moving. Therefore, whenever the body falls freely under the action of the gravity, it does not remain rest. Does it remain rest over there? No, it goes. It moves. Why? Because the body is having some velocity. How much velocity the body is having? That is your 2gh. Therefore, the body does not remain over there at the stationary position. Moreover, when the body reaches on the ground, this total energy which was there, when the body is coming into the rest, what is happening to the kinetic energy? You may ask. So body was having the kinetic energy, and when it reaches on the ground, it covers few distance. After that, it comes to the rest. Then what happened to the kinetic energy? And what happened to the potential energy? So initially I have told this potential energy convert into the kinetic energy. On reaching on the ground, maybe this kinetic energy convert into the heat energy, sound energy, etc. Whenever the body falls on the ground, then the heat energy is produced, and also one sound is produced. Therefore, this kinetic energy is converting into the heat energy and the sound energy. So therefore, the total energy, and at that position, if you find the total energy, it is also the same. That is your mgh. Whatever energy will be there, that will be your mgh. So this is the verification of k plus u is equal to constant for a body falling freely under the action of the gravity. Thank you.